Hi, welcome to another Rusty Maths video. In this video, we're going to be talking about conditional probability, but this is specifically for dependent events. I've already done a video about independent events, and you will need to use the word and. So for example, if two events, A and B, are dependent on each other, let's probably make that look like a B. If they are dependent on each other, it means that one event happening or not happening affects the other event. And the formula that we need to use for that one is if it's the probability of A and B happening, and B depends on A, then it means that it's the probability of A multiplied by, because we have to use multiply because and in probability means we multiply, multiplied by the probability of B given that A happens. Okay, so the probability of A and B happening for dependent events or conditional probability is probability of A times the probability of B given A has happened. Now you've seen this already, you just don't know it yet. If you watch my other video on tree diagrams, which I'll put in the description, then you would have seen this, but you just didn't recognize that you were doing it. So let's look at an example of how that might work. And for this one, what I'm going to do is I'm going to whip out my drawing skills again. So that's my my bag, and my bag's going to have counters in it. So it's going to have 10 green counters. I'm just going to put the number 10 for green, 10 green counters, and it's going to have 10 blue counters in it. Okay. And what's going to happen is somebody's going to pick a counter, they're not going to put it back, and then now they're going to pick another counter, and then I'm going to show you where you have done this before without actually even using this formula. So here we go. So for this, I'm going to start off with a tree diagram. Today, I'm going to show you two different kinds. I'll show you a kind where we use the tree diagram and a kind where we use the Venn diagrams, okay? So here we go. So I'm going to start drawing my tree diagram, and I'm going to put my information in this tree diagram. All right, so here we go. So this is my last little branch there. And if you saw my video on tree diagram, if you haven't, it's in the description anyway. If you saw my video on tree diagram, you'll see that the tree diagram will have different sections. This is going to be the first section and the second section. This first section is going to be where they've drawn for the first time. So this is going to, I'll write this down as the first draw. And this is the second draw. And I hope you don't get confused, but make sure you watch my other video on that. Now, if they're going to draw, when they put their hand in the bag the first time, they will either get a green or a blue. And the probability of getting green is going to be 10 out of 20. So I'm going to put my green there, and this is my blue here. And the probability of getting a blue is 10 out of 20 as well. Here comes the condition now. If a green has already been drawn, then the probability of getting another green, so I should probably label these green, blue, green, blue. So the probability of getting another green is now 9 out of 19. The reason why it's 19 is because I've already taken a counter out. It's a green counter. So I no longer have 10 green counters, I've got 9. And I no longer have a total of 20, I've got a total of 19. Now the probability of getting a blue counter is 10 out of 19. Probably should make that look a bit neater. So that's 10 out of 19. Okay, reason why is a green counter has been taken out already. So I've still got all 10 blue counters, but I still only have a total of 19. So everything on the second section of the tree diagram will be out of 19. You just got to think of what the top number is, okay? Now here, a blue counter has been taken out. So to get a green will be 10 out of 19 still. And to get a blue, 9 out of 19, okay? So that's the tree diagram filled in. Now let's put some people in here and make this a little bit interesting. And for this one, I'm going to pick, I don't know, brother and sister pair maybe. So I'm going to say the brother's name is Ben. And the sister's name is, pick something nice and short. Oh, why do all the girl name go? Okay, Lucy. Ben and Lucy. That sounds like the start of a TV show. Anyway, here we go. So we got Ben and Lucy. So it looks like Ben's going to pick a counter first, and then Lucy's going to pick a counter next, okay? Here is where things can get a little bit iffy. So I can say, what's the probability that Lucy, so find the probability that Lucy picks a blue counter given that Ben has picked a green counter. Let's just make it interesting, okay? What's the probability that Lucy picks a blue counter given that Ben has picked a green counter? Well, this is pretty straightforward, so let's just have a look and see. Ben has picked a green counter, so we're here. The probability now that Lucy picks a blue counter is here. It's just 10 out of 19. 10 out of 19. Why? It's because he's already taken a green counter out of the bag. So there are only 10 blue left, well, still 10 blue left and out of 19. And that's done. Literally, it is that easy. Now, here's where the difference comes in now. The difference comes in if we say, find the probability that both Ben and Lucy picks, I don't know, a blue counter. Both Ben and Lucy, oh, this can get rather confusing. Ben and Lucy picks a blue counter. Well, this one goes back to my video on tree diagrams. Ben picks a blue, Lucy picks a blue. So that's going to be just as straight as 10 out of 20 times 9 out of 19, which becomes 90 out of 380. And again, if you want, you can simplify it, or you can just leave it as it is. If you simplify it, 9 out of 38, if you please, okay? And that's the end of just this section now, where we talk about how do you use given or conditional probability. Let's look at another type of question where you need to use a Venn diagram, or a Venn diagram has been given to you. So here I've got a Venn diagram of a ski resort. So people have gone to a ski resort, and here are your various types of people, okay? So you've got people who can ski, people who can snowboard, and people who don't do either of the two. Now I need to explain what each one means. Well, the first thing I probably should explain is what your universal set is. So the total amount is your universal set. So you need to add this and that and that and that, and that should give you 274. So your universal set is 274. So we know that everything we do from here onwards will be divided. Well, not everything. We need to be careful with that. But 274 is our grand total, okay? Now, the other thing that I want to know is how many people are skiing. So, or how many people can ski. And this is going to be 150. Where did I get the 150 from? Well, I added 118 plus 32 to give me 150. And I also need to work out the people who can snowboard, and that's going to be 120. So I'm going to put my 120 there. And that includes the 32 people here and the 88 people. If you're looking at Venn diagrams for the first time, this can be quite challenging for you. So I hope you're familiar with your Venn diagrams, okay? So again, just to recap, I've added all of these to work out the total people at the ski resort. I've added these two because this whole circle are people who can ski, okay? So that's these two here. And this whole circle are people who can snowboard, 32 and 88, okay? Now, to make sense of a few bits and pieces, These people can only ski. They cannot snowboard at all. These 88 people can only snowboard. They cannot ski. These people in the middle, they can do both. They can snowboard and ski. And these 36 people out here can't do either of the two. They can't snowboard or ski. Maybe they're just bystanders. Who knows? But that's it. Okay. Now let's get straight into the probability bit now, where we need to work out some conditional probability. And I want to show you the difference between the two. If I now say, what's the probability of a person picked at random, any person that's picked at random can snowboard? Well, I have got a total of 120 people that can snowboard. So that's going to be 120 out of 274. That's a person picked at random. If I say, what's the probability of a person picked at random that can ski and snowboard? Well, these people in the middle can do it both. So that's going to be our 32 out of 274, because it's just a person picked at random. Easy. Okay. And just the same way I can go, if a person is picked at random, what's the probability that they can't do it at all? You know, that will be the 36. But here's the fun part. Find a person picked at random, okay? Sorry, let me rephrase that. We want the probability that someone can ski given that they can snowboard. So I'll jot that down. Okay, so here I've written it down. We want the probability that someone can ski given they can snowboard. So let's see where we need to go. I'm picking someone from the ski section. Okay. But I need to make sure that they can snowboard. So because they can snowboard, I need to focus on this total here. So basically what I'm doing is I'm actually calling all the people who can snowboard, which is 120 of them. I'm calling them over and I have them in front of me. Only those people that can snowboard. And I want to pick a person who can ski as well. So to find this one out, there are 32 people that can ski out of the 120 people that can snowboard. This is your conditional probability. Notice now that it's not out of 274, it's out of 120. So I looked at my snowboard and you notice that I haven't, even though I've given you a formula at the beginning of the video, I have not once used it. Mainly people who are doing A-levels tend to use that formula and they tend to see it in a different way as well. But I prefer not to use it if I don't have to. If it makes sense to you, then just go without it. But let's just suggest I have one of my viewers here is a geek and they would like to see the formula used. Let's use the formula then, okay? So I'm going to say that this is the probability, probably should get a pen going, the probability of someone that can ski and someone that can snowboard is going to be equal to the probability that someone can snowboard multiply the probability that someone can ski given they can snowboard. Okay, now I was really clever with this formula, so please make sure you look for little tricks, okay, that I've been using here. So ski and snowboard, you can't do anything about that because it doesn't matter which way around it is. I can have snowboard and ski, it doesn't matter, it's still going to be the same thing. But here, this is where it really matters, okay? Because I have worked out the probability that someone can ski given they can snowboard, I have ski given snowboard. This has to be snowboard, okay? So, you know, always keep an eye out for little tricks like that. If I flick back to the formula that I gave you at the beginning, you would have seen that there as well, okay? So this order does matter. Don't mix it up at all, okay? So don't mix this up. So the one on the end is always the one here, all right? Anyway, let's go and put this into practice then. So ski given snowboard, I should probably rearrange it first because this is what I'm actually working out, which is what I've done here. Okay, so I'm actually working that out. And to work that out, I'm going to say that probability that someone can ski and snowboard divided by probability that someone can snowboard is equal to the probability that someone can ski given they can snowboard. So I'm trying to show you that we'll get the same answer if we use the formula up there. Now, some of these things I've already got. So let's see what I've already got. I've already got the probability that someone can ski and snowboard. So that's here. Ski and snowboard is there. So that's going to give me 32 over 274. And I'm dividing by the probability that someone can snowboard. And I've done that already. That's up here. 120 over 274. So 120 over 274. And that should be equal to the probability that someone can ski given they can snowboard. I just realized that I might have left someone in the dust just now. So let's just go back and clarify a few things, okay? When I started this formula here, I've got the probability that someone can ski multiplied by the probability that they can ski given they can snowboard. This is a multiplication. When I want to rearrange this to make this the subject, I have to do the inverse of multiply, which is divide. So this needs to, by right, go underneath there, or divide. And then I played a little trick here as well. When I showed you the answer for the top, which was there, which is what we worked out there, rather than put this line, I've put this division here. It's the same thing. And I did it deliberately because I wanted to show you, I know what's going to happen with my fractions anyway, so I wanted to make sure that that worked out all right. Anyway, here we go. Now, we know from a long time now that in maths, when we divide fractions, it's the same as multiplying the reciprocal. So you change that to multiply and you reciprocate this one over here. If it's somebody from the UK listening to this, they'd probably hear something or like KFC, keep, change, and flip. So you keep this the same, you change this operation from multiply to divide, and you flip this one over. I don't know what they say anywhere else around the world, but I'm going to use the correct mathematical terminology, which is that you multiply by the reciprocal of your second fraction. Okay, so reciprocate means to flip over. All right, anyway, let's finish this because the video is going on. That will cancel out with that. And the minute they cancel out, we've actually got 32 over 120, which is exactly the same answer that we've got up there. All right. Okay, so that's the end of the video, guys. And I do hope that you have a better understanding of your conditional probability. You've seen it from a tree diagram point of view and from a Venn diagram point of view. If this video was useful to you, please give it a like. Share it with someone else that might need it. And don't forget to subscribe. Thank you very much. Thank you for watching.